Here is this year's course for Ohio State's Freshman Engineering Robotics Competition. It is modeled after a candy factory and sponsored by Nestle. So below we have the shop, and then above is the factory portion. The robot has to start when a light turns on, and then press a button and drive over to the other side where it pulls a pin out of a little tube, flips a switch, which sends candy rolling down into a little barrel by the shop area, has to pull a skid down from the factory into a freezer, and then it also deposits a scoop in one of two bins depending on what color the light is. For navigation, it has these lines on the ground and then an RPS navigation system that uses infrared above. To do all that, we have been assigned into teams of 4 and given a microcontroller as well as $160, and there's a store that they have set up full of robot parts that we can spend that money in. So that is the challenge, and this is the chassis that we've come up with to compete in it. So as you can see, it's got an interesting thing going on with the wheels. We're able to change the orientation of the wheels from there to there. So it's an omnidirectional robot without the Omni wheels. Omni wheels are expensive and they won't be able to go up the ramp very well. But we wanted an omnidirectional platform because we're going to mount one tool to each side, so it'll be specialized. This side will have the forklift that will pick up the skid and put it in the freezer. This side will press the button. This side will pull the pin. And theoretically, we won't have to change orientation at all during the competition, which should improve our time. This setup was inspired by the MK2 robot, and I'm going to leave a link to that below in the description. That's a really sweet robot that does the same thing. On the bottom, we have one servo in the middle that controls the angle of all the wheels. We have the two Vex motors that are mounted diagonally. These were just included in the store, so we went with them. The encoder wheels are actually made out of reflective foil, which helps increase the contrast and give us a better reading. We've got this just duct taped on. We're experimenting with different encoders. These little blocks are not final. We are also trying out a suspension on the non-powered wheels, because when we were going up the ramp originally, sometimes the powered wheels would lose contact with the ground if we didn't go at a perfect angle. So we added a little give to the non-powered wheels, and that ensures that we always have good contact with the ramp when we're going up, and that seems to have solved the problem. So let me open this quick and I'll show you the linkage system that's inside. So here is it exposed. That's the first orientation. And then there's the second. And as you can see, it's got 3 Vex gears in there. The pieces on top of the Vex gears is made with shape lock plastic, which is moldable when it's heated. All of the rods are made out of PVC, and then there's just little pins that hold everything together. We do need to make some alterations though. Right now, this wheel housing and this wheel housing aren't perfectly flush with the chassis, and that's because these rods aren't the right length. So we have to play around with that to ensure that all the wheels are perfectly parallel in either orientation. But other than that, it's worked pretty well. We still need to add the code that makes the wheel drive slightly when it changes orientation, otherwise it'll shift. But that's it for now. I will now play the video of the performance test. We have periodic performance tests, which are little increments that let us kind of break down the competition. So the first one was just going up the ramp, and then the second one is pressing the button, and it'll proceed from there until we get up to the final competition where we have to perform all the tasks at once. So I'll play that.
So then that light's off, that's red, so hit this and we're good. This is official. Okay. That's red. And now it's blue. Woo!